Let's move that over. Yeah, I don't see the tunneling. I need to log into that. I hope everybody can hear me good and see good. You can see behind me, I am back at the school now and streaming from there. So if you'll have to bear with me, there might be some technical issues to work through. All right. So let's, that was not Socrative. Me. I have to cut that out whenever I end the video. All right. So we've got a Socrative up. All right. What is the apparent power for the circuit in the figure below? Okay. So we have 120 volts, 12 amps, and 1200 watts. Well, the apparent power is going to be the total power in the circuit. We have 120 volts being provided to this circuit, and then 12 amps flowing in the circuit. So apparent power is just, I didn't put a paint. And I didn't set up my pen yet. So bear with me while okay. Okay. Oh, this is so much harder. R I E and P. So we have I is 12. Y'all thought my handwriting was bad before. I is 12, and E is 120. So I times E gives you P, and P is going to be 1,440 volt amps. That's going to be the answer here. The 1200 watts is the true power. True power is measured in watts. Apparent power is measured in volt amps. So that should have kind of tipped you off to which was the answer. All right, resistive power is also known as true power. True power is only in the resistors. Everything else is known as other things. All the powers and everything else is known as other things. Power factor is the ratio of the apparent power to the true power. Or the true power to the apparent power. It is the true power to the apparent power. So that is the formula for power factor. It is true power to apparent power. To find power factor, you just divide true power by the apparent power. So going back to question 1, we have 1200 watts and 1440 volt amps. You would divide the 1200 by the 1440, and that would give you your power factor. All right, power factor is a series circuit is defined as resistance divided by impedance. You can also find it with true power divided by apparent power, but those triangles are the same like they're the same ratios as each other. So if you take your resistance and divide it by your impedance, which is your total opposition to current flow in the circuit, you would still get your power factor. But that the resistance divided by impedance only works in a series circuit. Poor power factor is normally caused by inductive loads. Yes. Most of the loads in facilities are inductive loads. Things that are inductive loads like motors. Motors are the big one, really. But almost everything in a facility has an induction, or is mostly an inductive load. Which means to correct the poor power factor caused by an inductive load, you'll use capacitors, because those are the opposite and they will cancel out. The maximum benefit is realized when the capacitors are placed at the load. So the reason this is where the maximum benefit is realized is if the capacitor is at the load, it will be switched on and off with the load. So it will counter the load's induction every time the load is turned on, and whenever you turn the load off, it won't go the opposite way and cause a poor power factor because of too much capacitance. Because you can have too much capacitance whenever you overshoot your induction. But if you put it at the load, it'll always be on at the same time. That's why things like AC units and refrigerators in your house have capacitors in them, and that you don't just install a capacitor bank when you're building a house. Power factor is defined as blank divided by blank. Okay, that's just true power divided by apparent power. Kilowatts divided by kilovolt amps. That's the same question as number 2? No, 3. All right, what is the power factor for the three-phase load in the situation described below? An industrial plant has a 480-volt, three-phase, 500-amp bus which feeds a production line. And the load is largely inductive. The measured voltage is 460 volts. The measured amperage is 450 amps. The connected load is 275 kilowatts. All right. So again, this is just a combination of that first question that we did in maybe like the third. So calculator. I don't have a way to, there we go. So we have 460 and 450. Those are our volts and amps. To get true power, or to get apparent power, we're going to multiply those. So 460 times 450. So multiply. 207,000. This is three-phase. Anytime you're working with something three-phase, you have to multiply it by 1.73. That's better. That's just a rule for working with three-phase systems. And the key word that tipped you off to that is that it said three-phase. So it's voltage times amperage times 1.73. So now we have 358,110. Now we have to divide that by 275,000. Divided by, and I've got it written right here, 358,110. All right, enter. And that is 76.79. So that's going to round to 76.8%. All right, moving right along. A highly inductive 25 kilowatt load is operating a power factor of 63%. What value of capacitive kilovars is required to correct the power factor to 95%? Okay, so I need my drawing pad for this. Y'all give me one moment. I will be right back. Hopefully this just plugs in and works. Uh-oh. Okay, I will have to move you guys to the other screen. Give me 1 second to do that. Let's copy. Display capture, property. All right. Sorry if this got crazy for a second. Now I can move this over here. And I apologize if I'm looking to the side while I'm drawing, but it's a necessity. I will work on getting this set up better in a little bit. Looks a little blurry. Okay. So a highly inductive load, 25 kilowatt load, is operating at a power factor of 63%. So power factor what the fuck? Okay, work with me here. That worked. How is that? What is that? Sorry. Okay. Try to use the pen. Okay, I'm on the line mode right now. power factor is equal to P apparent over P. No, that's completely wrong. I'm sorry. P true. Sorry, using the mouse has fucked me up. Over P apparent. I really want to use this. Okay, so we have 20. What sort of setting even is that? It just makes a line. That's so weird. Okay. Troubleshooting is for later. So true power over apparent power. So that 25 kilowatts is the true power. And it has a power factor of 63%. So to get the let's see. I think at this point it would just be easier to show the explanation. I don't like their explanation. I don't like this. You guys give me a moment to straighten this out, and I will come back. I'm going to end the stream here. There's the camera. I'm going to end the stream. I will post a new stream link in a few moments with the rest of the stuff. I'm going to start the new quiz now, though.